I want to look at a different class of parameter tampering attack now, and it's a mass assignment attack. And the best way to explain how this works is to just show you. So here's what I'm going to do. I'm back on this user profile page. So this is the one where we just manipulated the hidden field to make me an admin. Now what I've done is reverted that change. I'm no longer an admin. We don't see admin up there in the navigation bar. And if I go and inspect the hidden fields here, we'll find that there is no longer a field for isAdmin. So I can't just go and tamper with the form like I did before, at least not in the browser. Now here's what I want to do. I'm going to hit F12 to close the developer tools, and I'm going to snap the browser window over to the right of the screen. I've got Fiddler running behind it. Now all I'm going to do is just save this form. And as I do that, you can see the request appear in Fiddler. In fact, you can see 3 requests. So the first request we can see to the user profile, that has an HTTP 302 result, which is a temporary redirect. So it sends the browser to another location. The second request is the location it was redirected to. And all that is a message that says, hey, your profile has been updated. That's the one we see in the browser to the right. And then the third one is a Google Analytics request. So nothing functional to do with this site, it's just tracking requests. Let's now jump over to Fiddler, and I'm going to stop capturing. Now here's what I want to do. I'm going to go up and grab that first request and drag it onto the Composer window. If we have a look at the request body down at the bottom right hand part of the screen, we can see that there is no isAdmin field. There's a user ID, a first name, and a last name. That's all that goes in the request body. But what if we were to add one? So what if we went over to here and added isAdmin equals true? Just like that. So keeping in mind that this didn't exist already, not in this example, there was no hidden field for isAdmin. All we've done is gone and added it ourselves. Let's now go and execute that request. And Fiddler does the same thing again, sends the request and then redirects. Now let's go back to the browser. I'm going to maximize the window and then F5 to refresh, and now I have the admin link back in the navigation bar. How did this happen? There wasn't an isAdmin field in the page. So what made this possible? Well, the concept of a mass assignment attack is that very often a web form is implementing what we call model binding. So it's taking a model, which in this case is a profile, and it's automatically binding any attributes that are sent in the post request to the model in the database. So even though the web application may not explicitly be sending that isAdmin flag in the request, the framework is automatically persisting any attributes that match the model from the HTTP request all the way down to the database. You see this happen a lot in more modern frameworks that make things easy for developers by automating this model persistence. So what is designed to be a convenience, and certainly it does make the process of building software easier, can actually be a risk if it's just automatically persisting every single attribute of the entity that's sent in the request. So that is precisely what a mass assignment attack is, taking that mass of fields and assigning them to the underlying model. Now this has also been used to great effect in the wild. In fact, back in 2012, we saw a proof of concept against GitHub where someone managed to add their own SSH keys to other repositories because of a mass assignment risk. And in that example, it was a vulnerability in the Ruby on Rails implementation. So this is a real risk, and it's a great example of just one of the flavors of tampering with untrusted data in order to exploit a system.